All right, let's get started on our second page. On our second page, I see there are 3 graphs waiting for us. There are 3 equations. The directions say analyze the equation of each hyperbola, then sketch the graphs of each of the following hyperbolas. There's a lot for us to analyze. We want to know the direction in which it opens. Is the hyperbola horizontal or vertical? And that's determined by the location of the transverse axis. Is that horizontal or vertical? Where's the center? Where are the vertices? Find the location of the foci and the asymptotes. The asymptotes are going to be really important. You'll see how all of this information sort of gels together, so let's get started. Opens. The x is the positive squared variable, not the y that's behind the minus sign. It's the x, which means this is going to have a hyperbola that's going to have a horizontal transverse axis, and we can expect the shape to do something like this when we sketch it. We're going to have it opening left and opening right at the same time. Where is our center? What I did not mention is, of course, these graphs will shift left, right, up, and down. Right now, we can determine that this is going to center at 0, 0. Why? Because we do not have any constants with the x or y being squared. Now let's analyze where are the vertices. Because it's going to open left and right from the center, I'm going to take the x-coordinate of the center and add and subtract the square root of 36, or 6 units. So 6 units left of 0, 0, and 6 units right of 0, 0. I can plot these points, and these are the 2 vertices. Now, I can't just sketch a graph, and I don't know if it's really narrow or if it's really tall. That will be determined shortly. Where the location of the foci. On the previous page, we learned that c squared equals a squared plus b squared. This was the formula that's going to help us identify the location of our foci. A squared is 36. B squared is 16. 6 and 6 is 12. 30 and 10 makes 40. That's 52. So c squared equals 52. C equals plus or minus square root of 52, but I feel like that can be simplified. 4 goes into 52 13 times, so 2 root 13 is the simplified version of the square root of 52. Next, what we're going to do is we're going to add these values to the x-coordinate of the center. So the square root of 52 is more than 7 units away. When I take out my calculator to approximate it, let's do the square root of 52, and we see that it's 7.21. So these are the exact values for how far left and right, but when I graph it, I want to go 7 units, 6, 7.21 units right, 6, 7, 7.21 units left. These are the locations of the foci. What were they again? To the left, -2 root 13, comma 0, +2 root 13, comma 0. These are the location of the foci. All right, here comes the exciting part. This is what's going to make or break your graph. What are the equations for the asymptotes? The asymptotes are going to pass through the center, so I want them to pass through 0, 0. The slopes of those asymptotes are determined by the change in y and the change in x. Square root of 16 divided by the square root of 36. So that's 4 over 6, which means 2/3. So the slopes are 2/3 and -2/3. I also wanted to pass through 0, 0. This is a point slope formula because I'm not subtracting to the x-coordinate and not subtracting to the y-coordinate. When we do a more challenging one, it's going to be important that we adjust the asymptote equation to pass through a center when it's not 0, 0. So this is what we're going to do. In order to graph this, we're going to use these equations for the asymptotes, but something I didn't talk about that's really important is on the front page, we noticed those graphs had rectangles. How do we make a rectangle that contains these diagonals? This way we don't have to worry about finding this equation first. So here's what we're going to do. From the center, we know that I want to go 6 right and 6 left. What we didn't talk about is that we're going to go 4 up and 4 down. This is our rectangle. Our rectangle will be 12 wide and 8 tall. What you're going to do is, just like we did for an ellipse, we're going to go horizontal, the square root of that number, vertical, the square root of this number, and this is what's going to make our rectangle. Our rectangle is formed here. What I can do is make it nicer and make it dotted like they did on the front page for us. And now you see this rectangle take shape. The asymptotes are going to go through the diagonals of this rectangle. So if I just draw a line, it's going to have to go up 8 and right 12 units. Up 8, right 12 reduces. Oh, that reduces to 2/3, doesn't it? Where do we see 2/3 from? 2/3 algebraically was the slope of the asymptotes. Positive 2/3, and here comes my negative 2/3. Down 2, right 3, down 2, right 3, down 2, right 3, down 2, right 3. These are our asymptotes. Now let's sketch a picture. We only know 2 points that are on the hyperbola themselves. They are the 2 vertices. What you want to do is, as you graph to the right, you want to get closer and closer to each asymptote. So as I go to the right, you want to get closer and closer to this asymptote. You don't want to get there too slowly, and you don't want to get there too soon. It looks something like this. Very rarely do I allow you to sketch a graph of a hyperbola with only 2 points, but we, even in Chapter 5, knew the asymptotes are what holds the graph in place. This is actually a rather accurate sketch of this graph. What I'm going to do is this a little bit differently the second time we go through this for question number 2. What I'm going to do is maybe let's draw the rectangle first and still analyze where it opens in the center. It's going to open up and down because the y is the positive. So how far up do I need to go? I'm going to go from the center. Let's see, where's our center? Our center is 0, 0. I'm going to go 9 boxes up, 9 boxes down. The rectangle is going to go 5 boxes right because that's 25 underneath the x, and 5 boxes left. So I can draw my rectangle by just filling in the horizontal and vertical sides from how we began to analyze our picture. Here's our rectangle. It has a center of 0, 0. Where are the vertices? Again, because the y is the positive, then in the y direction, 9 units away from 0, 0, are the location of our 2 vertices. Our foci, we're going to add 81 plus 25, that's 106. The square root of 106. Now the square root of 106 is more than the square root of 100. If I took my calculator to approximate this, I know it's more than 10 and therefore will be off the page. But let's get a sense. 10.295. Alright, so let's put the foci in. I'm going to go from the center, 10.295 up, 10.295 down. And these are the location of the 2 foci. So we're going to add the square root of 106 to the y-coordinate of your center. So I think that's not reducible as well. 106 is 53 times 2. 53 doesn't divide. Okay, the asymptotes. Now we did this by analyzing it, but let's see if we did it without analyzing it. From this diagonal, I need to go up 18 and write 10. 18 over 10 is like 9 over 5. And that makes sense because I have 81 over So I'd have the square root of 81 divided by the square root of 25. So our two equations for the asymptotes would be y equals positive 9/5 x and y equals negative 9/5 x. So I'm going to go up 9, right 5, that gets me to the center, up 9, right 5, that gets me to the other corner of the diagonal. That's one asymptote. I'm going to go from this diagonal, down 9, right 5, that gets me through the center. And now what? How do I graph the remaining part of this graph? From the vertex, get closer to these asymptotes. I don't really want to go straight across. I don't want to go just up here, but gradually sketch your picture in a reasonable amount of time. Make sure it gets closer to the asymptote. I feel like I needed to fix this one. I feel like it should have gotten closer sooner on this side. You have a good eye to do this. Here at the bottom, we're going to do the same thing. And this would be the picture of your hyperbola. I'm going to stop the video and do example 3 on the next one.